Find the LCM and HCF of 40, 36 and 126. This is a easy problem. We can directly prime factorize all the numbers. 40 is nothing but 2 into 20 and further 2 into 10 and further 2 into 5. Together I can write as 40 is equal to 2 cube into 5. Next 36 is simply 2 into 18 and then 2 into 9 and then 3 into 3. Together 36 equal to 2 square into 3 square. And last we have 126 can be written as 2 into 63 or 3 into 21, further 3 into 7. Together I can write as 126 is equal to 2 into 3 square into 7. Now what will be the HCF of the three numbers, that is 40, 36 and 126. So what are the common factors among all the three? It is simply 2 and the lowest power is in this case, that is 1. So it is simply 2. Therefore the HCF of all the three numbers is simply 2. Now the LCM of all the three numbers, that is 40, 36, 126. We now write all the factors, that are 2 into 3 into 5 into 7, and now we write the highest powers of each factor. So for 2 it is 2 cube, for 3 it is 3 square, and for 5 and 7 it is simply 1, and you calculate, you will get 2520. So LCM of all the three number is 2520. 3 bells ring at intervals of 6, 12 and 18 minutes. If all the 3 bells rang at 6 am, when will they ring together? It is given that at 6 am all the 3 bells rang. And the question is, at what time will they ring again together? All we have to do is calculate the LCM of 6, 12 and 18. Let us start with the prime factorization of all the three numbers, starting with 6. So 6 is basically 2 into 3. So simply 6 is equal to 2 into 3. Next is 12. 12 is simply 2 into 6 and 6 is further 2 into 3, or 12 is 2 square into 3. 18 is 2 into 9 and 9 is 3 into 3. Together 18 is equal to 2 into 3 square. Now we can write the LCM. Let us write all the factors, 2 into 3, and the highest powers of both are 2 square and 3 square, which will come to be 36. So what does this mean? It means that after 36 minutes all the bells will ring together. That is at 6:36 am, that is 36 minutes after 6 am, we have 6:36 am, and at this moment all the three bells will ring together. The largest number which on dividing 1251, 9377 and 15628 leaves remainder 1, 2 and 3 respectively. Let the largest number or the largest divisor of three numbers be denoted as Q. Now we can express all the three numbers as 1251 is equal to A into Q plus 1, because it leaves 1 as the remainder. We need not worry about A. A can be any number. 9377 equal to BQ plus 2, and 15,628 is equal to some CQ plus 3, and we can rewrite all this equation as 1250 is equal to AQ, 9375 is equal to BQ, 15625 is equal to CQ. We have to find the HCF of the three numbers to get Q. Q perfectly divides all the three numbers, leaving no reminders, and that Q will be the largest number that divides the three numbers, leaving these as reminders. Let us prime factorize all the three numbers. So 1250 is 5 into 250. We can write as 5 into 50, that is 5 into 10, and 2 into 5. Similarly, 9375 I can write as 5 into 1875. This will be 5 into 375, 5 into 75, 5 into 15, and this is 5 into 3. And last we have 15,625. This is 5 into 3125, and this is 5 into 625, 5 into 125, 5 into 25, 5 into 5. So in the prime factorized form, 1250 is 2 into 5 power 4, 9375 is 3 into 5 power 5, and 15625 is 5 power 6. So together the HCF of all the three numbers, the common factor is only 5, and the smallest power of the common factor is 4. So it is 5 power 4 or 625. Whenever we are seeing very large numbers ending with 5, simply you start with 5 as the common factor. That's a straightaway procedure. If it is an even number, you can reduce with 2. On a morning walk, 3 persons step out together and their steps measure 30, 36 centimeter and 40 centimeter. What is the minimum distance each should walk so that each can cover the same distance in complete steps? So in this problem, what we have to find is basically the LCM of 30, 36 and 40. That will give the answer for the minimum distance that each of the 3 persons should walk so that they cover the same distance in complete steps. LCM of 30, 36 and 40. So 30 is simply 2 into 15, and 15 is 3 into 5, or 30 is equal to 2 into 3 into 5. 36 I can write as 2 into 18, and this is 3 into 6, and this is 3 into 2. Therefore 36 is 2 square into 3 square, and 40 2 into 20, and 2 into 10, and this is 2 into 5. So 40 is 2 cube into 5. So to write the LCM, I have to write all the factors available, that is 2 into 3 into 5, and the highest power of 2 is 3. For 3 it is 2, and for 5 it is 1, and you calculate, you will get 8 into 9 into 5, or 360 centimeter. Have all of you understood this problem from a physical sense? For those of you who could not understand what this problem actually means, I will show you a physical description of what is meant or what is asked in the given question. This image is not exactly to the scale, but this is only for all of you to have an understanding of what is being asked in the problem. On a morning walk, 3 persons step out together, and their steps measure 30, 36 and 40 centimeter. So let the first person be A, and second person be B, and third be C. Okay, one in the red has the shortest step, so this is 30 centimeter, and the second one, the blue, he has 36, and the green has 40. Okay, you can see that in terms of step size. So this is the smallest one, and 36 is slightly larger, and 40 is slightly even bigger. So each complete step means this is one complete step for person C. So he has another complete step, like that. For person A, which has the shortest step, his complete step is even smaller. Okay, so all of them started their walk at some point here. Okay, so this is the starting reference, and they all started from this reference, and in this direction they are walking. And after walking some distance, let's say they reached here, all the 3 persons reached here, and they reached here in complete step. The person C made his complete step and he exactly reached here. Similarly, the second person B, with his complete step, he reached here, and with this complete step, person A also reached here. Let us say we are looking at some point here. Okay, now what happens? For person C, he made 2 complete steps. Okay, but for person B, his third step, he is actually in the middle of the third step. If he makes one full step, he will be outside this position. What we need is some distance from the starting line, and at that distance all the 3 person should complete his complete steps together. In this problem, when we calculate the LCM of 30, 36 and 40, we got that to be 360 centimeter. So this is the 360 centimeter. It starts from the reference, and it took 360 centimeter, and after 360 centimeter, all the 3 persons would have completed or would have reached this point with complete steps. One more variation can be asked in the same question, that is how many steps each of the 3 persons would have to make so that they cover the same distance in complete steps. Okay, so what we have to do here, at 360 centimeter, we observe that all the 3 persons will complete the distance in complete steps. So we just have to calculate the number of steps they would take, and that would be simply 12 steps for person A and 10 steps for person B and 9 steps for person C. A rectangular courtyard is 18 meter 72 centimeter long and 13 meter 20 centimeter broad. It is to be paved with square tiles of same size. Find the least possible number of such tiles. The first thing that we can do is that the length and the width of the courtyard is given in a combination of meters and centimeter. So let us convert everything into centimeter. So 18 meter 72 centimeter is simply 18 into 100 centimeter plus 72 centimeter, or 1872 centimeter. Similarly, 13 meter and 20 centimeter is simply 13 into 10 centimeter plus 20 centimeter, and together 1320 centimeter. We have the length and the width of the rectangular courtyard, and we have to find the least possible number of tiles that will fit this courtyard. Let us calculate the total area of this courtyard. So let the total area of the courtyard be denoted by the letter A, and that will be A equal to 1872 into 1320. We do not know the size of the tile, but it is given that it has to be a square tile. So let the side of the square tile be x, okay, and the number of tiles that are required to fill the courtyard, let us denote as n. So how can we relate this, the total area of the courtyard, to x and n? We can write area A is equal to 1872 into 1320 is equal to the area of one single tile, that will be x square, into the number of tiles. This is the equation which relates the total area to the size of one single tile and the number of such tiles which can fill this entire courtyard. How do we solve this? The thing that we have to imagine or understand is that the length of the square tile x, it has to be in such a way that it perfectly divides both the length and the width of the rectangular courtyard. Only if the size of the square tile perfectly divides the length and the width, we will be able to perfectly fit the courtyard with the rectangular tiles. Otherwise, we will have to cut some of the square tile like we actually do in our actual homes and buildings. This calculation is not done. We will start with some square tile that we like, and in most of the scenarios it will not perfectly fit our rooms or buildings, and the laborer will be cutting some of the square tiles so that it fits the carpet area. But in this problem, we have to find the size of the tile in such a way that it will perfectly fit the courtyard, and there is no scenario of cutting a tile. We do not make any cuts or modifications to the tiles. We just take the tile as it is and we will fill the courtyard. And that can only be possible if the size of the tile perfectly divides both the length and the width of the courtyard. And the second requirement is that the number of tiles that is required has to be the least. So we have to match two requirements. One is we should not make any modifications or cuts to the square tiles. Second, we have to use the least possible number of such tiles. Once more I will repeat, the side x of the square tile has to be in such a way that it perfectly divides, okay? It perfectly divides the length and the width of the rectangular courtyard. We have to find the highest divisor of the length and width of rectangular courtyard, or we have to find the HCF of the length and width of the courtyard. So let us prime factorize both the dimensions, starting with 1872, and that is 2 into 936, and this is 2 into 468, and this is 2 into 234, this is 2 into 117, this is 3 into 39, and 3 into 13. Similarly, 1320, I can write 2 into 660 and 2 into 330. This is 2 into 165. This is 5 into 33, and this is 3 into 11. So together I can write 1872 is simply 2 power 4 into 3 square into 13, and 1320 is 2 cube into 3 into 5 into 11. So what will be the HCF of 1872 and 1320? It will be simply 2 cube into 3, because 2 and 3 are the only common factors that we have, and their lowest powers are 3 and 1. So this is nothing but 24 centimeter. Okay, now we have this 24 centimeter that we have to substitute in this equation. Once again, what is this 24 centimeter? This 24 centimeter is nothing but the value of x, which is the side of the square tile. So I'll come back here. I will substitute the value of x square in this equation. So that will be 24 square into n, and you have to calculate yourself. You will get n as how much? 4290. So 4290 tiles is required to fill the courtyard, so that we do not make any cuts to the tiles, and also this is the least amount of tiles that is required. Find the greatest number of 6 digits exactly divisible by 24, 15 and 36. How do we solve this problem? We have to find the greatest number of 6 digits, and that should be exactly divisible by 24, 15 and 36. So we can understand that whatever number that we need to find, it will be a multiple of 24, 15 and 36. So the procedure will be, first we will find the lowest common multiple of the three numbers, that is LCM of 24, 15 and 36. And once we find the LCM, the multiple of that LCM we have to check to get the greatest number of 6 digits in length. So we will go step by step. We'll start with the LCM of the three numbers. 24 is simply 2 into 12 or 3 into 2 square. So 24 is 2 cube into 3. 15 is simply 3 into 5. So 15 is 3 into 5. And lastly 36 is 2 into 18, and this is 2 into 9 or 3 into 3. So 36 is 2 square into 3 square. So the LCM of all the three numbers will be, let us write all the factors, 2 into 3 into 5, and the highest factors are 2 cube, 3 square into 5 power 1, and the value will be 360. Okay, now we have to find multiples of 360 till it gets to the largest 6-digit number that will be divisible by 24, 15 and 36. So when we find the LCM of the three numbers, we got 36. What it means is that any multiples of 360 will always be divisible by 24, 15 and 36. Now we have to find the largest 6-digit number that will be divisible by 24, 15 and 36. For that we just have to find that multiple of 360 which is as high as possible. To do this, what we have to do? What is the largest 6-digit number? The largest 6-digit number is 9,99,999. Now what we need is the largest 6-digit number which is a multiple of 360. For that, what we can do is that we can divide this number by 360. We will do our usual division. So it is a straightforward process. Moving further, you will get 2520 and you will get the same remainder, and you have to do again. So this becomes a repeating scenario. So this will just go on. The division process will never end. It will continuously go on. So we will have this value also continuously going in. From this process, what we can understand, if I multiply 360 with 2777, I will get the largest 6-digit number that is divisible by the three numbers. So what I have to do is that 360 into 277, I will get 9,99,720. This is the largest 6-digit number that is perfectly divisible by 24, 15 and 36.